Auzubillahiminash-shaytanir-rajim. Bismillahir-rahmanir-rahim. Dear students, Assalamu alaikum. The topic for our today's discussion is confidence interval estimation and hypothesis testing. Before defining what is confidence interval and what is hypothesis testing through confidence interval, we review what we have studied yet in econometrics. Previously, we studied the stage 1 of the econometrics, that is to build an econometric model, defining the econometric model, where we have defined the variables of the econometric model, dependent, independent variable, the sign of relationship among the two variables, the type of the econometric model, and we studied the simple ordinary least square with only two variables. Then we have estimated the models and we have taken the estimates of the coefficients. We have taken the sample data and after analyzing the sample data, we calculated the numerical values of the coefficient of relationship between the independent and dependent variable. These estimates represent the population parameter, and we estimated the population parameter through sample data, and a single value of the coefficient explain or represent the population parameter. This type of estimation where only a single value we define, calculated, estimated on the basis of sample data which represent the population parameter is termed as point estimation. Of course, the major objective of the econometrics is to estimate the population parameter on the basis of sample data through coefficient sample coefficient of relationship among the variables, sample statistic, which also called sample statistics. Through sample we calculated the population parameter, we estimated the population parameters. Again, after the estimation, we conducted various tests of significance, and we stated that there are three tests of significance of the ordinary least square estimate. The one is economic priori criteria to judge the goodness of the coefficient estimated. The second one is statistical criteria that consist of R square and the hypothesis testing through standard error test, and third one is econometric test. And in the fourth stage we will see what we will study, but we focus on the third stage. In the third stage we have studied the uh, statistical criteria. We are studying the statistical criteria, and we have studied previously the two tests of significance. The one was R square and the other was statistical test of significance through T test and Z test. Here a question arises that how precisely a single point estimate can represent the population parameter. That is the important question. The population parameter is a fixed value. Population parameter doesn't change. Population parameter is not varying, and we estimated the population parameter on the basis of statistics that are calculated from very small sample. The sample coefficient of relationship which represent the population is a variable because it changes from sample to sample. If you take another sample of the same size, you calculate the coefficient value that will estimate the population parameter, that will be differ from the first estimate of through the first sample. That's why there lies an uncertainty in the point estimate, and point estimate are cannot alone uh, predict the that we represent the population parameter. And that's why along with the point estimation we also uh, calculate the interval estimation for our coefficient. What interval coefficient state? Interval coefficient state that our population parameter will lie in these two range. That will not a fixed value, but they will define the population parameter through range, that our population parameter will fall in this range, and that is something a rational approach towards estimating the population parameter. Let me start this with the next slide, studying the basic difference between the point estimates and interval estimate, and then we will study how confidence interval can be constructed. Again, then we will study how hypothesis testing is done through confidence interval test. Let's go ahead. Concept of estimation. We study from the slide. The objective of estimation is to determine the value of population parameter on the basis of sample statistic. We have previously told that what is the basic objective of our estimation of taking sample. We are estimating the population parameter on the basis of the sample statistic. There are two types of estimator. The one is point estimator, that we have estimated the coefficient value through ordinary least square, and the other is interval estimator that we will study today. So we start from the point estimators. Previously we formulated a regression model and estimated the point estimates of the population parameter. We have already done it, and a point estimator draws inferences about a population parameter by estimating the value of unknown parameter using the single value or point. How point estimator estimate the population parameter? We take a sample, and from the sample we calculate the representative of the population, the statistic, sample beta naught cap and beta 1 cap. We estimate beta naught cap and beta 1 cap, which we state that probably these beta naught cap represent the beta naught, and the beta 1 cap is representing the beta 1, that is the population parameter. The point estimator alone cannot accurately predict the population parameter. Yes, it is an efficient and uncertain to predict the population parameter through uh, point estimates. There lies uncertainty which damage the reliability. The point estimator are supported by interval estimator. Yes, there lie uncertainty in point estimates. How? As we have studied previously that the population parameter beta 1 and beta naught are fixed. They doesn't change. They just doesn't vary. While the sample estimates beta naught cap and beta 1 cap are changed from sample to sample. And if you take n number of sample from a population, every beta naught cap will will be different from the other beta naught cap, and so on and so forth. So we have to calculate the interval estimation as well to support the point estimator. Here we see that how we estimate the model through point estimator. The population parameter estimated by point estimation by using the following equation. We previously used these equations. The population regression function is y is equal to beta naught plus beta 1 x plus mu, and the population regression line, that is the expectation of this population regression function, that y is equal to beta naught plus beta 1 x. This is population regression line, and we cannot directly observe the population parameters, so we have to calculate these population parameters through We have to estimate these population parameter through calculating the sample statistic, that is y cap is equal to beta naught cap plus beta 1 cap x plus e, that is sample regression function, and y cap is equal to beta naught cap plus beta 1 cap x is equal to sample regression line. Here beta naught and beta 1 are the population parameter which are obtained estimated through point estimator. The sample estimates are beta naught cap and beta 1 cap are the point estimators. What we have estimated yet are the point estimator. Now we see the more in-depth the point estimator, where we state a point estimator draws inferences about a population by estimating the value of an unknown parameter using single value or a point. We can see here the red point on the sample distribution in the middle of the distribution is a point estimator. We see here that is the, sorry, that is not the point estimator, that is the expected value of the uh, point estimator. And look at here that there are 1 2 3 4 5 6 7. We have taken 7 sample, and a 7 sample has estimated different parameters, and we say that these all represent this point estimator, this expected value of the coefficient. So we see here that the point estimator, the population value or the expected value of the estimator will remain same fixed, and from the sample to sample the sample statistic will change, which is representing the population parameter. So we have to need, along with this estimate, the confidence interval to precisely show where the population parameter value lies. Interval estimator. Now we study the interval estimator. We will study from the slide. So interval estimator we study from the slide. There is another method through which we can estimate the population parameter is called interval estimation. A confidence interval estimation is the type of estimation for the population parameter beta naught and beta 1 through the sample data, but the estimate is an interval of a number instead of a single value estimate like a point estimator. Here is we will estimate the population parameter through a range of values, and we will define the lower limit of the confidence interval and upper limit of the confidence interval, and we state our population parameter lies within this range. The confidence interval estimate of the population parameter beta naught and beta 1 are the interval of number with lower limit and upper limit calculated through sample data. The confidence interval range of estimate include the population parameter. Of course, we say that this range include the population parameter, where we state that we are 95% confident that the value of population parameter lies in the estimate. This confidence level depends on the level of significance. If you have alpha, that is 5%, then confidence level will be 1 minus alpha, mean that 1 minus 5% mean 95%, that we are 95% sure that our uh, value of the confidence our value of the population parameter lies within this confidence interval range. What are the rationale of calculating the confidence interval? What are why we calculate the confidence interval? We study from the slide. The point estimates of beta naught and beta 1 are the random. These are random. I say that the point estimates of beta naught and beta 1 are random. Those estimate change from sample to sample, and question arise that how accurately we fix a fixed value point estimate represent the population parameter beta naught and beta 1. That is an uncertain question. There lies a greater uncertainty which is that how close are the sample estimate beta naught cap and beta 1 cap to their population parameter beta naught and beta 1. The confidence interval estimate are used to reduce the level of uncertainty. The confidence interval estimates is an observed interval calculated from the observed sample data used to indicate the reliability of the some point estimates. Yes, increase the reliability. How frequently the observed interval estimates contain the population parameter beta naught and beta 1 is determined by the confidence level of the confidence interval estimate. That how we are sure that how we ascertain that our population parameter lie in this range depend upon the level of significance. Mean that a 5% level of significance mean you are 95% confident that your population parameter will lie in this CI range. And of course, you need more confidence. We need more confidence that we can say that we must 100% confident that our population parameter lies in this range. But to reduce the alpha, that is level of significance, we will increase the probability of type 1 error. So we have to optimize the confidence interval, confidence level and the alpha. And for economics, the optimal level of alpha is 5% and confidence level is 95%. Let's suppose we have 5% of level of significance which states the 95% level of confidence. The 95% confidence level states that if we take 100 sample from the population, listen carefully this, the 95% confidence interval state that if we take 100 sample from the population and calculate the confidence interval estimate for every sample, then the 95 out of 100 estimate will contain the population parameter in their range, while only 5 estimate will not include the population parameter in their range. So we are confident 95% mean 95 confidence interval that are estimated through sample data will contain the population parameter, but only 5 will not contain. The proportion of the total confidence interval estimate that contain the population parameter is called confidence level. Right, now we study about the formula for interval estimator. Of course, the interval estimation is carried out on the basis of the beta I cap. The beta I cap that we have estimated through ordinary least square, a point estimator. On the basis of the point estimator, on the basis of the standard error of the point estimator, and on the basis of the critical values of t, we calculate the confidence interval. Look at here, Ci is equal to confidence interval is equal to beta I cap, beta 1 cap, let's we suppose this is beta 1 cap, beta 1 cap plus minus t alpha by 2, that is critical value, and into standard error of the beta 1 cap. Look at, see, there are three component of the confidence interval. The one is beta 1 cap, that is estimated regression coefficient through ordinary least square, that is the point estimate of the population parameter, plus minus critical value t alpha by 2. These values come from the table. And the third one is standard error of beta 1 cap, standard error of the regression coefficient. So we can, putting the values of these, we can calculate the confidence interval which will provide us two ranges, right? When we plus the TC and standard error, TC into standard error of beta 1 cap in beta 1 cap, we will have the upper limit of the confidence interval, and we will, when we will minus the from beta 1 cap the values of product of critical values of t into standard error of beta 1 cap, then we will see a lower value of confidence interval, that is called lower limit of the confidence interval. with n minus k degree of freedom. The degree of freedom is n minus k, where n is the number of observation and k is the number of coefficient that we have estimated through regression line. Usually we use 5% level of confidence, level of significance, which state that 95% confidence level means we are 95% sure that the value of population parameter will fall in the estimated interval. So we see here that we calculated the confidence interval through t-test. The phenomena is same as previously we have stated that if we doesn't know the population standard error and population variance of the beta 1 cap and the sample size is less than 30, we will use here t critical values. If we knows the population variance and standard deviation for beta 1 cap, either if the sample size is greater than 30, then we will not use the t critical values, but we will use z critical values to construct the confidence interval. So this was the basic formula of the confidence interval. We will go ahead now. Look at here that this is a pictorial view, a pictorial explanation of the uh, confidence interval estimates. Here this green color represent the total population, where we see here that the mean mu is unknown, mean that standard error is unknown. We have taken a sample here and we have estimated the beta 1 value, that is 50, from the random sample, and then we calculated the confidence interval, and then we say that I am 95% confident that the beta 1 lies between 40 and 60. A confidence interval provide a range, and here we see that the range is between 40 to 60. This is the phenomena of confidence interval estimate, which is explained with a picture. What factor affect the interval width? What determine the width of confidence interval, that it will be a very huge interval or it will be a very narrow interval? How, what define this interval or width of the confidence? Three things determine the uh, width of the confidence interval. The one is data variation. If data is varying and the variance of the data and standard error of the data is very high, then the confidence interval will be high. A higher confidence interval means that inaccurate estimate of the population parameter. For example, if we state that the income of a person lies between 0 and infinity, so it's for sure that everyone income lies between these, but we will lose precision here. We will lose precision in constructing the confidence interval if there is a very high variance. So a lower confidence interval will remove the uncertainty and will create preciseness in our estimates about the population parameter. So higher the variance mean that high will be the confidence interval. As previously you see here in the formula of the confidence interval, we use here standard error of beta 1, and the standard error of the beta 1 is the under root of the variance of the beta 1, and the variance of beta 1 we calculate through the variance, population variance as well. So if higher variance, higher standard error will generate a higher standard of the coefficient and will generate a large confidence interval. The second one is sample size. The sample size, as we know that the standard error is inversely proportional to the under root of the sample size. Mean higher the sample size, the lower will be the standard error and variation or variance of the population variance and the variance of the respective estimate. So higher the sample size means the no narrower will be the confidence interval, and we will estimate the population variant with more precision. And third one is level of confidence. If you uh, increase the level of confidence, means that your confidence interval will also be very large. If you reduce the confidence level, right, your precision will be more and your confidence interval will shrink, right? And these are the three major determinants of the confidence interval, size of the confidence interval. We see here that interval extend from beta 1 cap minus t alpha, yes, t alpha by 2 and standard error. Yes, the interval extend from this is the minus 1, this is the one side of the one limit of the convergent interval, that is beta cap I minus t alpha by 2 into standard error, and the other limit of the convergent interval is calculated by beta 1 cap plus t alpha by 2 into standard error. So this was the end of the construction of the confidence interval. This is the part 1 of the this lecture. In the next part, inshallah, we will discuss how we will do hypothesis testing through confidence interval approach. Allah Hafiz. Assalamu alaikum ji.